Okay, good morning again, guys. This is lab 6-3, Zener diode voltage regulation. Okay, the objective of this is to demonstrate the connection and operation of a Zener voltage regulator circuit. So the purpose of this lab is to explore how a Zener diode may be used to control the maximum voltage across a load by connecting the Zener diode in parallel with the load. This type of voltage regulator circuit has one major drawback, which is it is not very energy efficient, mainly for the fact that it is dropping voltage in its series connected shunt type resistor. Okay, they're going to ask us to connect up as they've the diagram that they've shown in procedure 1. So figure 1, what we've got is we've got our DC supply here. We've got basically on the last lab they asked us to just have a 15 volt Zener connected up. We left it in a reverse bias state, and then it is connected up in series with a 500 ohm. Now what we've done is we've added a 5600 ohm resistor in parallel with that Zener diode that is reverse bias in connection with the source voltage. So in doing so, I've got 3 meters, well 4 meters I guess, connected up. They asked us to have a meter going across the 500 ohm resistor, which I have here. Okay, oops, sorry, let me pan down to this so that you can actually see what I'm talking about. Okay, and I'll zoom in a bit. All right, I'll move over a bit. That'll work. Okay, so we've got a 500 ohm resistor voltage to be looked at here. We've got our source voltage that they didn't ask us to do, but I've got that so you can see what voltage we're at. The total current, which once again they didn't ask us to do, but we can document that current is flowing in the circuit. And then our 5K ohm voltage resistor, or the voltage drop across the 5K ohm. So this is the 5K ohm resistor, this is the 500 ohm resistor, and then there's our Zener connected up in reverse bias. So let's just power this sucker up and see what happens. Okay, so no circuit current, no voltages, things like that. So the first step that they ask us to do is to take it up to 5 volts. So we're going to take our source voltage, which is here, up to 5 volts. Okay, so we're about there. So then the series resistor and the load voltage. So the load voltage is the 5K ohm. So that load voltage is sitting at 4.7. And then we're about 0.4 at the 500. So 4.7 at the load and 0.4-ish at the series connected resistor. Okay, so we're about 5.1. They add up together. All right, increase it to 10 volts. Getting there. So we're almost 10 on the dot. Okay, we've got our Zener, or sorry, no, our 5K6, so that's our load, is sitting at 9 volts now, or 9.2. Okay, and our 500 ohm resistor, which is our series one, is sitting at 0.8. So they add up to 10. And we do have a little bit of current of 3 milliamps flowing in the circuit. We're going to go up to 15 now. So we're about 15.2. So our 500 ohm resistor, which is our series connected one, is sitting at 2.2 volts. And we are at 12.94 on the load. So we can almost call that 13, or 12.8 I guess. Okay, because we're at 15.1, so they'd add up. All right, then they ask us to go to 20. Now this is going to be interesting because now the voltage is going to be over what our 15 volt Zener would be. And I think in the last lab we recognized that our Zener voltage was about 14.3 to 14.5. So once we achieve that, we're going to see that that's going to stay steady and regulate. Okay, so we're going, whoops, I went way past it. We want to go to 20. So we're at 20 there. My 500 ohm resistor is sitting at 7 volts. So that's my series one, 7 volts. And this guy's sitting at 13. at the load. Okay, so then we're going to go up to 25. So we're at 29, come on now. We're at 25 out of our source. We're at 14 there at our load, and the remainder is going across that, that resistor, the 500 ohm, at 11 volts. So 11 volts, and still sitting at the 14, okay, adding up to 25. Now the lab stopped us at 25, but I can tell you this, if we keep increasing, I'm just going to take this up to say 40 volts. Come on. Okay, we're about 42 volts. This load is still being regulated at 14.5 volts there. Okay, so the Zener is doing its job. Now circuit current, total circuit current is continuing to increase. Our series connected resistor is heating up. We got 27 volts being dropped across it. That's because we're sitting at about 42 volts. So this guy is doing its job. It is regulating the voltage, okay, and we could continue to carry that up and up and up, but we run the risk of burning out some of the resistors here. Okay, so that was, then they asked us to de-energize, clean up your work area, and then we'll talk about the observations and conclusions in our learning hub. So that was lab 6-3, Zener diode voltage regulation. And we'll see you on the next one.